Welcome to Master of CheMOMstry, where motherhood and science collide. In today's video, I'm going to tell you about the time that I accidentally drank nail polish remover and then connect it to the science behind an ingredient that you can find in nail polish remover called acetone. My name is Joy, and I'm a mom and a teacher, and my passion is to share my experiences with others and to connect those experiences to concepts and science. If you enjoy watching today's video, please make sure to hit the like button, the thumbs up button, as well as subscribe to my channel so you can get the latest notifications and updates when new videos come out. Now let's get to it, the story. How exactly did I accidentally drink nail polish remover while pregnant? How does that happen? Yeah, it's weird. Yeah, I was embarrassed. It's been almost 10 years and I'm still really not sure I want to tell people I did this, but here I am. Well, it was one hot July evening. I'm giving you the setting here. And I was heavily pregnant. Very, very, very pregnant, probably within about a month of the due date. And I decided I needed to do something to get my mind off of the aching back and the heartburn that was real horrendous. And painting my toenails seemed like a fantastic idea. Plus, I could do it in bed and be mostly horizontal while doing it. I don't really know if I thought through whether doing this was wise or if I could actually do it, because if you look at that picture there, I don't think I could see my toes, let alone reach them. But somehow I did make it work. It did happen. Now you need to imagine that I waddled to the bathroom because there was no normal walking at that point in the game. And I was gathering the essential materials. So let me show you examples of my essential materials. The nail polish remover, right? And the nail polish. And then I chose to use Q-tips to dip into the nail polish remover to help wipe off the nail polish. Something that I want to point out that maybe has nothing to do with this video, but I think it's weird, maybe you can relate, is I actually thought for probably longer into my youth than necessary that Q-tips was what you called one of these items. I know now that they're called cotton swabs and that Q-tips is a brand, but I thought Q-tip was this. Same thing with Kleenexes. I thought Kleenex was the tissue, not that Kleenex was a brand of tissue. Anyway, let's move on. Now, what ended up happening is with my nail polish remover, there wasn't a whole lot left. So because I couldn't reach it with the Q-tip, or if I tipped it on its side, it was going to end up spilling out onto my bed. Remember, that's where I was painting my toenails. I decided to pour what was left of it into a drinking cup. Yes, a drinking cup from my kitchen that I normally will drink liquids out of, like water and juice. So for me, that made it easier to dip the Q-tip in and access the nail polish remover. The next step was that I actually went through the process of removing the nail polish and painting my toenails. Done. What I didn't really think through is where I had left the remaining acetone in my drinking cup. I left it on my bedstand. Now, I already know you know the end of this story, but let's go through it anyway. That same evening, I decided that I better have water, which is pretty typical. I'm going to have water. I'm thirsty. And I ended up having a very similar cup. Just imagine these two cups now are both on my bedstand, one with acetone and one with water. Of course, being pregnant, I probably got up to go to the bathroom 4 or 5 times. So let's just say it was the third time that I got up to go to the bathroom. And then when I was getting back into bed, I wanted to get something to drink. So, and I, at that point, must have been really thirsty because I grabbed a cup and I gulped whatever was in it. You know what happened here. What I gulped was a nail polish remover. I didn't really even realize it until kind of after a couple of secondary swallows that wasn't water. Put yourself in my shoes, and I want you to think about what thoughts may have crossed your mind after you realize you drank nail polish remover. One, I thought that the baby probably was going to be affected, possibly could die. I thought maybe I could possibly die. I woke up my husband, I cried, I worried. What do we do? Do I go to the ER? What do I do? It's too late to call my doctor. So we thought it through, and probably about that that first or second appointment that we went to see our OBGYN because of the pregnancy, they sent home a packet of information, and I believe that there was a magnet that had poison control's number on it. Went to the fridge, got the magnet, called poison control. Now you might be thinking, how come you didn't just look it up on your cell phone? This was in 2010. So at that point, my husband and I, neither of us owned a smartphone. We could have looked it up on our very slow computer that took forever to start. But at that time, poison control on our phone, dialing it was the best bet. What did the poison control representative tell me? Well, first of all, they were very kind and very respectful. I did something that was really weird and almost laughable. They asked me a lot of questions like, what are the ingredients in the nail polish remover? What does it say on the bottle? How much did you drink? And of course, I made sure to let them know I was pregnant, which is why I was the most worried. What they told me was to ingest as much water as I possibly could to help to dilute it. And if I was having any respiratory issues, pain, or anything that would tell me something is wrong, or problems in movement of the baby, then go ahead and go to the ER to get evaluated. And then make sure to follow up with your doctor the next day. At this point, you might be wondering, how did it turn out? Was I okay? Was my unborn baby okay? Before I tell you the rest of the story, this is where motherhood and science collide. What I want to do is tell you a little bit about nail polish remover, and specifically focus on the ingredient that can be found in nail polish remover called acetone. What is nail polish remover? Well, we can break it down pretty easily, right? It removes nail polish. The liquid that you put from the nail polish remover bottle onto your nails that contain the nail polish will help wipe it away. There are some different ingredients that you can find in nail polish remover. Key ingredients, meaning the active ingredients, which include things like glycerin or ethyl acetate or acetone, and that's the one that we're going to focus on. What is acetone? Well, acetone is a colorless liquid. It can be found in nature, biologically made by living things, and then it can also be utilized in industry, manufacturing to make products. And of course, you can find it in nail polish remover. Now, you might have just heard me say that acetone is colorless. And you might have a bottle of nail polish remover that one of the ingredients is acetone, but it's not clear. If there are other ingredients in addition to the acetone, it could give it a particular color. The next thing I want to talk about is what is acetone in terms of its chemical formula. What is it made of? A chemical formula tells you which elements are bonded together. It also will tell you how many atoms of each element are found in that compound. In acetone's case, the elements include carbon, that's the C, hydrogen, that's the H, and oxygen, that's the O. When elements are bonded together in a particular way, that gives that substance special characteristics, also known as properties. And acetone happens to be in the category of organic substances because it contains the element carbon. An organic substance isn't like the pesticide-free organic vegetables and fruit you find in your grocery store. It's organic because it contains carbon that's bonded to hydrogens, oxygens, nitrogens, sulfurs, phosphorus, and there's others as well. When we're talking about organic, then what is like the opposite of that? The opposite, or the other category of substances, would be inorganic. That would include water, or acids and bases, and salts. And so those typically will not contain compounds with carbon in them. Now that we know what category acetone belongs, how exactly is it a key ingredient and useful when we put it in nail polish remover? Well, acetone is a solvent. A solvent is something that can dissolve another substance. So imagine that you have water and you have a sugar cube or a spoonful of sugar. When you put that sugar into the water and you stir it and you let it sit for a little bit, eventually you cannot see the sugar anymore. If you drink it, you can taste it, you know it's still there, but you cannot see it because it has dissolved. When we're talking about solvents and the things that they dissolve, we're talking about a solution. A solution contains two things, a solvent and a solute. The solvent dissolves the solute gets dissolved. In the case of nail polish remover, the solvent is acetone, which is dissolving the nail polish, so the nail polish is the solute. Something else to consider about acetone is the safety aspects of it. Don't light a match near acetone because it's flammable. Don't get it in your eyes because it could cause eye irritation and damage. And don't drink it. If you do end up bringing acetone into your body through ingesting it, then some things that could happen as a consequence are related to your central nervous system. So you could end up getting dizzy, feeling nauseous. And of course, this all depends on the amount that you drink. Your central nervous system includes your brain and your spinal cord. And that is like the CEO of your body. It's the boss. And it's making some major decisions pretty much all the time. So you really don't want to mess with that system. Just how dangerous then is drinking acetone? Well, it might surprise you, based on what I just said, that it's actually pretty low on how toxic it can be to our body. Obviously, you don't want to drink large amounts, but smaller amounts, it's not actually that big of a concern. Here's why. Acetone has another property that seems like maybe it shouldn't be. Remember how we said that acetone acts as a solvent, it can dissolve things? Turns out that acetone can also be dissolved in things, so it can also be a solute. Acetone is soluble in water and oils and fats. When we're talking about things like water and fats, you need to realize that your body is made up of about 2/3 water, depending on your age. And it also contains a whole lot of fats and very similar biological molecules that make up your cells, that are found in your cells. So if acetone can be dissolved in those things, that means it's going to easily become part of your biological system. Now, this might sound scary, but acetone isn't actually foreign to your body. We make acetone. Our liver does it actually. So sometimes our body will use fat that we've already stored up, and it will want to break it down to provide energy for our cells. In this process, besides making the energy needed for the cells, we'll also have a byproduct in the form of acetone. Now, I just said something there about our cells going through a process of breaking things down. This is part of our metabolism. Let's talk about metabolism quick. Metabolism includes all of the chemical reactions that occur in our body. This is being done by our cells. There's going to be processes that build things up and processes that break things apart. These chemical reactions are keeping you alive because they're keeping each individual cell alive. Our cells need to maintain something called homeostasis, and homeostasis is a stable internal condition. It doesn't mean that your cells sometimes just sit around and do nothing. No, they're always building things up and they're always breaking things down, but there's always this kind of neutral level that is occurring that's keeping them at a normal state. When you're not in a normal state, that's when there's disease, disorders, and dysfunction in your body. So our cells, by going through all these metabolic processes, are keeping themselves alive, and then overall, because our body is made up of living cells, keeps us alive. When you bring acetone into your body, it enters the digestive system, and your cells are going to want to do something with it. They're going to want to use it for some sort of biological purpose. So chemical reactions are going to start happening to it. And that's a good thing. And thank goodness that does occur. And through that process, it's going to be broken down into smaller parts. And some of those parts then can be released in different ways, such as released in your sweat or released in your urine, or we can breathe it out, depending on what the substance is. And in this case, when acetone gets broken down through our cells' chemical reactions, one of the byproducts is carbon dioxide. Carbon dioxide is something that we, humans, and other living things will breathe out. Plants, for instance, will use carbon dioxide and bring it in to go through the process of photosynthesis to make sugars. And you also know that it's in our atmosphere. Carbon dioxide is CO2, one carbon and two oxygens that are bonded together. We make carbon dioxide when our cells go through a special process called cellular respiration. It's a process that uses the foods that we eat and breaks them down to help make energy for our cells so that our cells can do all that work that they do to maintain homeostasis. Now, if we get too much carbon dioxide building up in the fluids that surround our cells or are inside of our cells, we can actually run into a problem because carbon dioxide can make that environment more acidic. To understand what acidic means, let's start with something that is not acidic. Water is not acidic. Water is not basic, which is the opposite of acidic. Water is neutral. Something that is acidic is like vinegar. Something that is basic would be like baking soda. The majority of our cells will actually stay around that same neutral level as water. Around, not exactly the same, but near it. So water has a pH of 7. 7 is neutral on the pH scale, and pH scale is a way of measuring how acidic or how basic a substance is. There are a few areas of the body that are exceptions to the rule that have more acidic environments or more basic environments. For instance, stomach acid residing in our stomach can have a pH between 1.5 and 3.5, and our liver bile can have a pH around 8, which is a little more basic. Now, we've talked about this acidic environment that carbon dioxide could cause if too much builds up. Why is that an issue? Why do we care? Remember what we talked about metabolism? We said that your cells going through constant chemical reactions, building things up and breaking things down. Well, one of the things that is highly involved in these processes, and one of the things that the cell actually puts together, are proteins. Proteins have a lot of different jobs, meaning they can be in charge of a structure. They can be in charge of moving things. They can act as antibodies, which are part of the immune system. They can act as hormones to communicate messages from one part of the body to the next. And they can help transport materials from inside to outside the cell or vice versa. And there are other jobs as well that I didn't mention. As you can see, there are a lot of different kinds of proteins. And there's a special type of protein called an enzyme. An enzyme is known as a biological catalyst, which simply means something found in living things that can help chemical reactions occur at a faster rate. Meaning, if the enzyme is not present, it would take a really long time or very special circumstances to make a chemical reaction occur. In terms of the human body and of other living systems, enzymes are absolutely crucial. There are some chemical reactions, whether they're the ones that are being built up or broken down, that require a certain amount of energy to actually occur. And that amount of energy would require our body temperatures to be at a point that would not be survivable. And so because these enzymes are present, these chemical reactions can occur and help us maintain our homeostasis. Each of these enzymes, though, is not the same. Each has a special shape to it. Its special shape is going to be very specific to another substance or substances that it interacts with for the chemical reaction that it was made for. So the special shape or location where the other substance fits in is called the active site. And the other substance that fits into that active site is called a substrate. And when that substrate or substrates fits into the active site or active sites, then a chemical reaction will occur, either building things up or breaking things down. If the substrate and the enzyme don't fit, no chemical reaction will occur. Keep that in mind. Now let's go back to that acidic environment that could possibly occur because carbon dioxide is building up, right? You ingest acetone, it starts getting broken down by your cells, carbon dioxide is released. Carbon dioxide is increasing, and now we have a more acidic environment. What's the problem? A slightly more acidic environment can actually change how atoms bond in a protein. And remember, an enzyme is a type of protein. So if the enzyme's shape changes and that active site is no longer the same shape as it was before, now the substrate that's supposed to fit into it can't fit anymore, and no chemical reaction will occur. This is called denaturation. Here's the conclusion from all this. If the environment changes and some of the proteins can no longer do the jobs that they were supposed to do, that means your cells, your individual cells, might be struggling to maintain their homeostasis, to do the reactions that they're supposed to do. And if that is happening in more and more and more of the cells, you're going to end up with a system-wide emergency. Don't want that. Fortunately, though, we can breathe carbon dioxide out, and our cells do have some special mechanisms in place to help adjust pH. In summary, the reality is if you ingested a small amount of acetone, your body would know what to do with it, to process it. Now, of course, if you drank larger amounts of acetone, that's going to be more dangerous in the case that your cells can't keep up with breaking the materials down. Back to my story. How did it turn out for me? Was I okay? Well, as I told you, and as it makes sense to the information I explained, yes, I ended up being just fine, and my unborn child was just fine as well. So if you ask about my mental and emotional health, that wasn't so good. I didn't sleep all night. I thought of all the terrible things that could happen to me or the baby. But thankfully, none of those things happened. Yeah, it's a little bit of an embarrassing story. But here I am sharing it with you today, even though I didn't share it with too many people back then, and hoping that you can relate to this story or learn something from it. One of the things that I'm trying to do with my videos is keep them at a point that's relatively basic and simple for anybody to watch. So there may be pieces of the scientific information that I should go deeper into, but I'm not going to. Unless you ask me and you want me to make another video about it, I certainly would be willing to do that. You might be wondering where I got my information from. I studied biology and chemistry in college, and then I've been teaching science in middle school and high school science for many years. I also made sure to validate the information that I was sharing with you by using reliable websites that had expert information on them. And speaking of websites, I have linked many of the websites that I used to verify my information in the description below. One more item that I want to point out is that there are documents that you can find online called safety data sheets, SDSs. And these sheets are provided by the manufacturers of a chemical, and then those documents are given to the entities that buy them. It'll include things like what it is, what it's like, what it looks like, what are its properties, safety considerations, what to do in case of accidents, and there's more than that. I linked an example of that in the description below. Lastly, when an entity has chemicals that they have bought, they need to have that SDS available to their employees to be able to view and utilize in terms of knowledge and in case of emergencies. Let's wrap this thing up. So as a mom and a teacher and just a person, I always like to share my wisdom with others. So I have 3 things for you. Number 1, if someone you love or a friend or anybody happens to ingest something that is questionable, call 911 or call poison control. Contact information for poison control, phone number and website is in my description. Second, acetone is a very useful chemical and it can be found in nail polish removers. And when you're using it correctly, it works great. When you put it in drinking glasses, it doesn't. So don't pour it in drinking glasses. All right. Third, educate yourself. We have a ton of information at our fingertips. Make sure though, as you're researching information about chemicals and about how your body works, that you are using websites that are valid, reliable, and have accurate information from the experts. Do you have a story like mine? I'd love to hear it. Share in comments or in the About area of my YouTube channel, you can find my email. Do you have questions about the biology or chemistry that I covered? If so, please let me know. I'm more than willing to answer it or look for the answer if I don't know, and potentially even make a video to go more in depth with that topic. And finally, if you enjoyed this video, please make sure to like it and subscribe to my channel. Our experiences can teach us so much, and I love sharing them with you. Thanks for watching.